Welcome back to the Network Plus training series. In this lesson, we are covering Objective 2.3. Given a scenario, configure and deploy common Ethernet solutions. Ethernet is the dominant technology for wired local area networks and has evolved significantly since its creation. In this lesson, we will cover Ethernet standards, wireless networking concepts, and how to deploy these solutions in real-world scenarios. Let's begin with Ethernet standards. Ethernet has evolved through multiple generations, each increasing speed and capability. The IEEE 802.3 standard defines wired Ethernet. 100 base TX, also known as fast Ethernet, operates at 100 megabits per second over Category 5 or higher twisted pair cable with a maximum distance of 100 meters. While largely superseded in modern deployments, you may still encounter fast Ethernet in legacy environments. 1000 base T or Gigabit Ethernet operates at 1 gigabits per second over Category 5E or higher cable with a maximum distance of 100 meters. Gigabit Ethernet is currently the standard for most enterprise access layer connections. 10G base T operates at 10 gigabits per second. Over Cat6 cable, it supports distances up to 55 meters. Over Cat6A, it supports the full 100-meter distance. 10 gigabit Ethernet is commonly used for server connections and backbone links. For fiber optic Ethernet, 1000 base SX uses multimode fiber with a maximum distance of 550 meters. 1000 base LX uses single mode fiber with distances up to 5 kilometers. 10G base SR uses multimode fiber up to 400 meters. 10G base LR uses single mode fiber up to 10 kilometers. 40G base SR4 and 100G base SR10 are high-speed multimode fiber standards used in data centers. Now let's cover wireless networking. The IEEE 802.11 standard defines wireless LAN, or Wi-Fi technology. Understanding the different Wi-Fi standards and their characteristics is essential. 802.11a operates in the 5 GHz frequency band with a maximum theoretical speed of 54 megabits per second. 802.11b operates in the 2.4 GHz band at up to 11 megabits per second. 802.11g operates in the 2.4 GHz band at up to 54 megabits per second. 802.11n, also known as Wi-Fi 4, operates in both 2.4 and 5 GHz bands with speeds up to 600 megabits per second using MIMO or multiple input, multiple output technology. 802.11ac or Wi-Fi 5 operates in the 5 GHz band with speeds up to several gigabits per second using MU-MIMO. 802.11ax or Wi-Fi 6 operates in both 2.4 and 5 GHz bands with improved speeds, efficiency, and performance in dense environments using OFDMA and MU-MIMO. Wi-Fi 6E extends 802.11ax into the 6 GHz band, providing additional spectrum and less interference. The 2.4 GHz band offers longer range but slower speeds and only 3 non-overlapping channels, 1, 6, and 11. The 5 GHz band offers faster speeds but shorter range with many more non-overlapping channels. The 6 GHz band, available with Wi-Fi 6E, provides even more channels and is less congested. Band steering is a feature that encourages dual-band capable devices to connect to the 5 GHz or 6 GHz band instead of the more congested 2.4 GHz band. This improves overall network performance. Let's discuss wireless network identifiers. The SSID, or Service Set Identifier, is the name of the wireless network that users see when searching for available networks. The BSSID, or Basic Service Set Identifier, is the MAC address of the access point's radio interface. The ESSID, or Extended Service Set Identifier, refers to the SSID used across multiple access points in the same network. There are several types of wireless network deployments. An infrastructure network uses access points to connect wireless clients to a wired network. This is the most common deployment type. An ad hoc network, also called peer-to-peer, allows wireless devices to communicate directly without an access point. A mesh network uses multiple access points that communicate with each other wirelessly to extend coverage. This is useful in outdoor deployments and areas where running cables is difficult. A point-to-point wireless link connects two locations using directional antennas.
Wireless security is critical. Wi-Fi Protected Access 2 or WPA2 uses AES encryption and is the minimum recommended standard. WPA3 is the newest standard, providing stronger encryption and protection against brute force attacks. Never use WEP, as it is severely compromised. For wireless authentication, there are two main approaches. Pre-shared key, or PSK, uses a shared password that all users enter to connect. This is also called WPA2 Personal or WPA3 Personal. Enterprise Authentication, or WPA2 Enterprise and WPA3 Enterprise, uses 802.1x and a radio server to authenticate individual users with unique credentials. Enterprise mode is more secure and provides better accountability. Guest networks provide internet access to visitors without giving them access to internal network resources. Guest networks typically use captive portals, which are web pages that users must interact with before gaining network access. Antenna selection affects wireless coverage. Omnidirectional antennas radiate signal in all directions and are used for general coverage. Directional antennas focus signal in a specific direction and are used for point-to-point links or to extend coverage in a particular area. The distinction between autonomous and lightweight access points is also important. Autonomous access points are configured individually and operate independently. Lightweight access points rely on a central wireless controller for their configuration and management. Lightweight APs are preferred in enterprise environments because they simplify management and enable features like seamless roaming. Let's wrap up. Ethernet solutions span from fast Ethernet to 100 gigabit Ethernet using copper and fiber. Wireless standards have evolved from 802.11b to Wi-Fi 6E. Proper wireless security, authentication, and antenna selection are essential for deployment. For the exam, know the speeds, distances, and media types for each standard. Thank you for watching this lesson on Objective 2.3. In the next video, we will cover Objective 2.4 on physical installations.